we're back. All right, let's see if I can actually get back into the screen. Is this us? That's us. Wrong section, but that's all right. We're up. We can relabel after. There we go. 60. There we go. All right, so we have RA plus RB with respect to A has to be equal to RC plus RB with respect to C. And those vectors always have to add up no matter how this thing is oriented. Like that, it's got to make that parallelogram. So then we could say VA plus VBA equals VC plus VBC. And now we've got constraints on position and velocity. General process is that you solve constraints on position and then plug positions into velocity. It's just usually you need to know where the thing is so you can tell how fast it's moving. It's like general kind of. So we knew like where the hinges were, so we were doing trig to figure out like, all right, how do I solve that first equation? How do I set the RA, RBA are equal to RC plus RBC? So then the last step was, once we knew all that trig of like sines and cosines, we're taking positions, solve, plug in, solve again, and now we'll end up with two equations, two unknowns, because we're trying to solve for how fast theta 2 is changing and how fast theta 3 is changing. So we have like an L1 theta 1 dot. And those two equations have to be true no matter what, like at any point in time, as long as the hinges are still connecting the parts. I'm just pausing for stopping and asking questions.
Why do you have theta dot? Is that first one the position?
This is like our Vx components and our Vy components. Like if I think of like how fast point A and point B are moving relative, like point C and point O have to have zero velocity. So we're looking at like based on how fast A and B are moving from O and C respective. Their x components have to add up to 0 because the total system is not moving. It's spinning around in circles, but that one I always have trouble like thinking about vector, like velocity vectors, because there's like multiple components kind of changing. So usually I always start with positions and then take a derivative to get to velocity. But you could have looked at like directly velocity B with respect to A, velocity A, compare that to O and C. And then did we get to the point where we were solving? Did we get to like any real numbers?
No, I think the first thing was L1.
L1?
And then, no, I have the ratios for the sines and cosines.
Sines and cosines. Do we have, so I have written here like sine theta 2, cosine theta 2. Do you know what sine theta 3, cosine theta 3 are? Done? So let's.
Oh wait, yeah, that's the part of it.
Oh, okay.
If you didn't,
All right. So we're like doing some trig based on just the position of A to O, like that vector. We know that like sine theta 1 is the x component of where A was over the length of L1, like that yeah, kind of where that thing is. And then same thing with y component. We could say 0.15 is that sine component there. What about for theta 3? What are the opposite and adjacent components there? The SOHCAHTOA, right? So we know L3 is the hypotenuse. So what's the y component for the sine, and then what's x component for cosine? And we're doing this rather than solving the position constraint equations. Like if we know the positions, then it's easier to solve for those sines and cosines rather than solving like two unknowns in a nonlinear, like sine and cosine. Yeah.
I was wondering why we're subtracting the 0.15 from the sine theta 2 and adding 0.0 from the cosine theta 2.
This one for cosine theta 2. We'll catch up in a second. Actually, just want to make sure. All right. No. So what we're doing there is like if we look at, scroll up a little bit, like this is how you get to A. You kind of travel up and to the left. So if I want to go from A to B, so B with respect to A, B slash A, I have to move the same distance, that 0.2 along A that they just traveled backwards, plus whatever, like from O to B to get there. So point B is 1/2 and 0.86. So I move forward 1/2, but to get there from A, I also have to move that 0.2 that I traveled backwards to get to A. Because point A is -0.2, So really it's describing like the relative position. So R B equals B slash A plus R A. So I'm saying, like, if I take position of B minus position A, that's the relative position of B to A to each other, like relative of. So this is saying B with respect to A is the position B minus position A, where this one is L2 cosine theta 1. Oh my god. I'm sorry, theta 2. Oh wait, these are just the positions. My bad, sorry. This one is going to be 0.5 minus a negative 0.2 along the I. So I'm saying, like, if I know RA and RB, I can take those X components, subtract them, X, and then Y components, subtract them, and set that equal to the equation that I know that I need to deal with, like the L2, cosine and sine, like that.
Yeah, that because everything's given relative to the initial point O.
Yeah, since I know like what the positions are, and even if they were like different, if I just knew like where they are, then I don't need to solve the constraint equation. You could plug that in directly, right? Since we have like I have two equations with two unknowns here. It's just now you end up with you're trying to solve for sine and cosine. Like it's not a linear equation. It's nonlinear because we have sines and cosines for that theta 1, theta 2. So you could solve it this way. Like take theta, at least if we know one of them, right? Like if we know theta 1 or theta 2, we could try to solve for the other ones. All right, cool. So what do we think opposite and adjacent are for theta 3, like sine theta 3, cosine theta 3? Yeah.
Where, so like, you have that, I guess,
Okay.
how do you draw the rest of the triangle with that? I guess it's a stupid question, but like, for theta.
For theta 3?
Yeah, so it's, you know how it's like on the outside?
Yeah.
You just.
But that's okay.
That's just kind of confusing for me.
Yeah, yeah. All right, let's do that. Grab it. I think we have like our trig unit circle. Oh. So if that one's theta 3, then this is going to be like a negative L3 cosine theta 3. I mean, cosine theta 3 will be a negative number, right? Like, I don't need the negative sign, but it's because theta is more than 90 less, right? Looking at cosine 2 pi. Not a great cosine curve, but we're somewhere in here, right? Quadrant 2, so cosine values are all negative. So can we just plug in that 0.86, like RB there?
This is just the way you drew on the unit circle. It's just the height of, or the y component of that pink arrow.
Yeah.
And you're starting from the ground, so I think it's fine.
Okay, cool. Yeah, we can use that same equation, right? Like RB is RB/C plus RC. RC has no y component, so we're not subtracting. Like we're saying 0.86 minus 0. Cool. What about for cosine theta 3? Minus 1.
Only one to the right, and so we need to like subtract it.
Like 0.5 minus 1. What do we think?
You ever going the distance from O to B in the x, and just the x way.
Mm-hmm.
That's what that is. Oh, or no.
Yeah, we're saying like the position of B minus position C. So if I move to the right 1/2, subtract that negative 1/2 to say how to get there. Or sorry, subtract that negative 1. Because really, to get from C to B, we're moving negative x.
You mentioned components, like the direction of the x component of R, B/C, it looks like it's going to
We're just trying to get the x component between C and B, right?
We're trying to get R of B/C.
From C to
The
B.
picture.
From C to B.
Yes. We want that x component of that.
Yeah, so this is O to C minus the distance from B to O, or B to O.
Mm-hmm. Nah.
I guess I said it backwards, but it doesn't matter. It's cosine.
Mm-hmm. And how do you plug in? What's your preferred? What do you do with two equations, two unknowns?
System of equations.
Yeah. Yeah, we've got equation 1, equation 2, trying to solve for theta 2, theta 3. What do you do with that one? How do you solve it? Does anyone do linear algebra? Yeah?
This is totally different, but in the 2024, 2025 catalog, there's no linear algebra, but it's in linear systems. But you don't learn it until the last semester. So you never learn linear algebra. I feel like it's something that should be used for solving.
I know. Yeah. I know once in a while it comes up. It's like, why isn't linear algebra like base engineering approach? But yeah.
Just use a matrix to solve it.
Yeah, you could plug it into matrix, set up system of equations as matrix vector. Yeah. Or calculate. What does the calculator do? How do you set it up in that one?
Using an add process.
Okay. What does it do?
It solves systems of equations.
Yeah.
It's like a matrix.
But does it set it up as a matrix? Like, are you plugging in components?
Like two equations.
Yeah.
Two equations.
Yeah, it sets up two equations with one coefficient, and then the left-hand term of the equation would be like a constant.
Yep.
And then there's two of those equations in the calculator.
Okay. Yeah. So what's the constant here? What do we set up as the constant part? If we're doing like system of equations.
Probably the left-hand side, or not the left-hand side, but the left term with L1.
Yeah.
L1.
Yep. In here, it's so let's get it into some form that we can actually solve it. So here's equation 1, there's equation 2. We want to take the stuff that we know is constant. Oh, why did I do that? Get the equal sign. So I know there's like some stuff that's constant there, and then my right-hand side is the stuff that I'm trying to solve for. Kind of rearranging the equation into what do I know, what do I want to know. And believe it or not, you're doing linear algebra in that case. Like, you're setting up a vector and system of equations in terms of like matrices now. Because you're saying like, okay, this is my like left-hand side 1, left-hand side 2, like a vector. And really there's like a negative sign there, right? This is all, you're always going to deal with radians when you're doing like actual math. Otherwise there's a factor of 2 pi over, or sorry, pi over 180. It gets, or 180 over pi, sorry. And it's there, it's always there, but it gets like masked. So math, anything with sines and cosine is always radians. It's never, degree mode is just like a function that they added to multiply 180 over pi times whatever, or pi over 180. Just plug it in there. Cool. All right, what do you get? What do we think? Oh, L1. Yeah, 0.25.
Dot one is one. And theta two is
Trying to,
one.
I realized that.
Theta three
That was not
is
too nice to do.
2.57.
I guess theta dot two is 0.1. Yeah. Or 9.
Yeah.
Yeah, bro. One, bro.
You get the same now.
Yes.
Yo, what was this guy? He said 0.99 instead of 1. That's crazy. 3.9 warrants a 1.01.
Yeah. Isn't there like some math that says if you oscillate between 0 and 1, the average is like 112?
Yeah.
It sounds retarded. Okay, no, I don't know. Why would it be 112?
I have no idea.
Also, remember I was there and had 0.9. Yeah.
When did you learn from that? Bro, all I know is pi equals 3.
This was like a long time ago. Cause like you think of 1/3, 2/3, 3/3, 1/3 is bigger.
Oh yeah, shit.
Is he like a Taylor series? What are you cooking over here?
I don't remember the logic.
See, just do that in your calculator. Just 1. Okay, stop for your own. It's 1 over 3. Decimal. 0.33. 2 over 3.
Great, wait, I actually don't understand.
No, this one's 0.6667. They are the one.
Why do we do 0.494 minus 1? Why do we do that? For the data 3. So you go. I know, I'm just trying to understand. So from 0 to C is 1 minus
1 minus this distance to get this distance.
yeah, 1 minus 0.494. So why is it negative?
It needs to be negative since it's going to the negative version.
I was going to say it's negative intuitively.
Well,
It also doesn't matter because cosine is even function. But yes, intuitively it should be negative. I don't know why it's different in those, but like, yeah, so they, I agree with you. I agree with you, my friend.
because of the Russians, you'll add the factors of the
Dude, same deal with this guy. It's like close. I saw Instagram videos of this dude. It's like, more people need to start coming up with phrases again. I'm losing my marbles over this. I was saying, like, start saying funny things. What happened to you? When he used to say crazy shit. Like, he didn't try to like, follow this guy. We as a society, it's not saying, get a load of this guy. And everybody kind of normalized not saying it. It's not even that. You're not crashing out. You're losing your marbles.
We've got updated English.
Crashing out versus losing
Brain rot. We don't have
I love brain rot. think I sent you green right yesterday. I sent you some pretty good screen. I sent you like, let's see. Let's pull up the tape. Yeah, I have like 4 videos. I'm underqualified for all of them.
Oh, I think that'd be before. I've seen it except like where it's editing something connection with sprinkler and it runs out.
You will never catch me go through this ever. That's literally. Yeah, we have Wednesday master. 12, 5. Oh no! Oh no! This one's good. This one's good. Plus 1. Reason's how to run it out. Yeah, well, that's good.
My TA is actually like basically lied to me.
For what?
For my exam.
Which exam?
For the philosophy exam.
Why?
Because we were like, which is not a character trait, like a style. And like one of the words we didn't even say that was 19 of these pictures of the campus were like and she was like, yeah. And so I was like, okay, well that's kind of like in passive just means passive.
It really goes in capacity, it goes to apathy.
And yeah.
That's the story.
They lied.
They lied.
I got her.
I didn't. First of all, primal crowd. The other ones were like Dark Souls. And it was like Fire the First Kills, like a McDonald's on. I just got, dude, this weekend my big event was I bought myself and I bought I got a PS5 and I splurged I saved up enough. I didn't start playing it yet. Granted, I got it on Sunday. I want to play it next weekend and over break.
We all 10 ratings.
I'm bringing back up to this room. I got controllers. I'm bringing the weekend.
Yeah,
I moved one game. Oh, it also came with like
After watching it,
You guys.
no, it came with Astro's players. Like that's like the song edition.
That's it's like a showcase for like features of the controller.
But it's still a good game. Yeah, Elden Ring is like it's one, bro. 0.99 ground.
Yeah, so I was just taking a look at like the calculator. It's been a while, so I always use like Python to solve everything, so it's been a while since I actually used a calculator, like probably since, I don't even know if I used one, maybe in grad school. Like I don't know the last time.
Did you ever see MATLAB for the big systems arrays?
Yeah, yeah,
That's a pretty good one.
yeah, MATLAB
I'm a
works.
big MATLAB guy.
Because there's just like, there's so few times where it's like, you're not allowed to use anything except a calculator anymore. Like everything's like, just go solve the problem. So I'm like, all right, plug it into Python, plug it into MATLAB or Julia. Like there's so many other good reproducible resources. But anyway, so like system of equations, we had like something x plus something y equals something x plus something y equals something. So we're like plugging this in, right? So over here we had 2.5 times Oh. Something like that. Does that match up with what you were trying to do? What did we end up with?
1 and 2.569.
You have to leave that number.
Unless it, because the first one was like 0.999 I'm like, yeah, that's 1.
2.9?
No, it was 2.5.
Oh, 2.5?
Oh, yeah, sorry, 2.569. I said two things at the same time.
What do we think? Did anybody else get similar numbers? Nobody? Just waiting for similar numbers? All right, similar, something, some 2.57? Oh, 2.57? 57? Do you want to see like Python how to do it? Like,
You also, is there a way to like upload it to our thing so we can like reference it?
yeah,
Okay, that'd
Yeah.
be really cool.
yeah, if you want. So with Python, we can either set it up as like, okay, this is a linear algebra problem, solve it for me, or we can say, this is a system of equations, solve that for me. So linear algebra is nice because it's like, it doesn't really matter how many unknowns you have. It's always the same process. System of equations, you gotta like you're making like a function to say this is the equation. What do we want to do? Linear?
And it's less specific, so.
Yeah. Okay. All right, so let's try linear algebra.
I don't have that, I don't know if I assume it's
So for that left-hand side, when we're setting up this system of equations, really what you did in the calculator was you set up a matrix for the calculator to solve. So we're just going to plug that in directly.
Is A that, you're defining A to be that first row?
Yeah, A is going to be row 1 and 2. So it'll have 2 columns, 2 rows, a 2 by 2 matrix. So the first value, negative 0.86 plus oh yeah, I need 2. So I'm taking those things that we just plugged in for system of equations, just plugging them into rows and columns in a matrix.
But not the equals part.
Yeah, not the equals part. All we need are the coefficients. All we care about are the numbers in there. Like it's very much once you have a matrix and system of equations, all the variables are weens. Do we need to minimize the chat? Man, I don't know what's going on. All right, and then our right-hand side, like the thing that we're trying to solve for, that's going to be our 2.5. And once we have everything kind of set up, now we can say like, okay, solve A comma B. And it should give us the same answer that we just got.
So you're just calling a function, you're calling a built-in function that already exists within Python?
Yeah, so no matter how many equations and how many unknowns you have, if you set it up as like a matrix and a vector, then you end up with like, okay, solve A and B. And we get the same answer that we just got. It's nice. And I'm pretty sure calculators have like a matrix solver like that. I don't remember how to do it. I remember that it exists.
It's like if you the inverse X button, but like press second, that pulls up the matrix editor.
Oh, okay.
And then you like enter in your matrix, and then the one for there's a command for like reduce row echelon form.
Okay. Yep. Yeah. You see it. So you can. So we were talking in the back, like someone had done linear algebra and they were trying to remember the steps to like do Gaussian elimination, that process. Yeah, so you can invert the matrix. For a 2x2, it's 6 of one, half dozen the other. But if you have like a 6x6 matrix, never invert it. Like it's never worth inverting a big matrix. It's just extra computational work. Like even if you're using a computer, just use a solver. MATLAB's kind of nice because it would just be A \B, and then you're done. But still, just it's nice to just have like a solve, like give me the answer button. Whoa, there we go.
Post that in like the SBC just for reference.
Yeah.
I think it'd be really, especially for like projects.
Yeah, that's fine. I don't know, like a Cookie Monster kind of emoji, right?
Yeah, Google couldn't afford like the normal ones, so they just did like even knockoff.
Cool. And then like the next homework problem is the same thing. Like we're here, if I pull up. Well,
No, we already have our like formula.
Can we skip to the formula that we derived for this one?
yeah, so and the main thing is like we went through the process of figuring out what are constraints on this general kind of 3 moving parts that are connected. So you can jump right into like, all right, let me just plug in sines, cosines, theta dots, and solve for theta dots there. So at that point, the only extra part is that things are a little bit different because we changed where it's mounted. Like now we're move over 1, down by 1/2.
Do we know that dx and dy rotate at all? Is that
No, those are the distances.
are those like fixed in place?
dx and dy?
Yeah, because the other bars in the linkage rotate. When we made our equation for I and j,
Yeah.
we only left it as dx and dy without cosine or sine.
Yeah, so dx and dy are like constant values because we're saying like O is here, C is over 1, down 1/2.
The constant values, do they go away when you derive? Do they go away when you derive through velocity?
Yeah, so the change in dx is always 0. Like dx dt is always 0.
So if you use those in the position equation, but then when you derive from position to velocity, the dx and dy go to 0.
Yep.
Because those are just constant distances between. That's to express that there's. We had dx, and it's just to express there's certain distance between O and C.
Yeah. Yep.
So it's the same problem.
Yeah, at this point, like this one is 0 and 0.25. And then here we've got like over 1 and up by 1/2. And then so when you draw it out like this, some of it starts to make sense of like, all right, theta 1's got to be about 90 degrees. Theta 2, also about 90 degrees, right? Or sorry, it's theta 3, my bad. It's basically vertical, yeah. Not quite. Yeah, yeah. Because really when we say like,
Are the angles in the same places for the last couple?
yeah, angles are, at least if you want to maintain the same, if you don't want to rederive the system of equations and relabel like theta equals 0, is that each thing would be like down along the x-axis.
So just to be clear, so theta 1, it's supposed to be the angle between A and the horizontal?
Yes.
Yeah, yeah. And that, so in general, that's a nice way to label like moving parts, is that when the angle is 0, it's flat, like flat on the ground, like that. And it's a nice, that way you always know that it, yeah, as the angle increases, you're increasing that slope like that. Otherwise, you have to like rederive stuff. Cool? All right, you have the power. Knowledge is power. Knowing is half the battle. Yeah, tomorrow night. So one more, plug in values, hit solve. If you want to use Python, go for it. If you want to use calculator, that's okay. As long as you're setting up 2 equations, 2 unknowns, there's got to be some way to get to an answer, right? We know that the answer exists. I think I'm getting more popular on YouTube, so something's happening.